In Lesson 6.2, we'll be studying similar polygons. We will learn to identify similar figures and solve problems involving scale factors. How do artists use geometric patterns? M.C. Escher was a Dutch graphic artist known for drawing impossible structures, spatial illusions, and repeating interlocking geometric patterns. The image at the right is a print of Escher's Circle Limit 4, which is actually a wood cutting. It includes winged images that have the same shape but are of a different size. Also note that they're not only similar dark images but also similar light images. When polygons have the same shape but may be of different size, they're called similar polygons. Two polygons are similar if and only if, so that means it's reversible. The corresponding angles are congruent and the measures of the corresponding sides are proportional. This symbol, which in Spanish we'd call a tilde, is read similar to. So in the example, these two quadrilaterals, angle A is congruent to angle E, angle B to F, C to G, H to D. So they've marked the congruent angles with the same number of arcs. And if I take 5 divided by 2, I get 2.5, 6 divided by 2, 8 divided by 2, 10 divided by 2. So again, all of the corresponding angles are congruent and the corresponding sides are proportional. In this case, the proportion was AB was 5 and EF was 2.5, so the proportion 5 over 2.5 would be 2 to 1 for each one of these. For example 1, they ask us to determine whether the pair of figures is similar and justify our answer. I do not have corresponding angles congruent. 40 is not the same as 50, so that's going to be no. So if we're looking for a yes, we want corresponding angles to be congruent. For example 1b, angle C would have to be 40. 180 minus 60 plus 80 is 140. And angle R would have to be 60. 180 minus 120 is 160. So our corresponding angles are congruent. Let's angle A is congruent to angle, the other 60 is angle R. Angle B is congruent to angle S, is also 80. And angle C is congruent to angle T. And then we want to see if our corresponding sides are proportional, which they're going to have to be if the corresponding angles are congruent, but we'll just make sure. AB was 5.2, and that lines up with RS. So divided by 3.9, I get 1.3 repeating. For BC was 7, lines up with 5.25 for ST, and I divide and I get 1.3 repeating. And last one, AC. Okay, so we'd have 8 is to 6 is also going to be 0.3 repeating. So this is a big yes. And justify my answer is what I did. When you compare the lengths of corresponding sides of similar figures, you usually get a numerical ratio. This ratio is called the scale factor for the two figures. Scale factors are often given for models of real-life objects. An architect prepared a 12-inch model of a skyscraper to look like a real 1,100-foot building. What's the scale factor of the model compared to the real building? Well, we know that 12 inches is the same as 1 foot. They gave us the actual building was 1,100 feet. The feet would cancel out. Anything divided by itself is 1, even units. So our scale factor is 1 to 1,100. two polygons are similar, write the similarity statement, then find x, y, and uv. Now, just because the vertices are in alphabetical order, they don't necessarily correspond in the same way. We have to look at the angles, the way they're marked. Now, they've marked the corresponding angles with the same number of arcs, but this is a good idea too. They said using different colors to circle the letters of congruent angles may help you identify the corresponding parts. We can try it. Feeling any better? No. So our similarity statement looks like ABCD is similar to RSTUV. Going from big to smaller left to right, AB is 6, corresponds to RS is 4, and that's proportional, so I can go X is to, and X corresponds to 3. And then we could do cross products. So 18 equals 4x. So x is 9/2 if we reduce the fraction. We'll do the same thing for y. So I'm going to start off with 6 to 4 again. So I'm going left to right or big to small. And 8 lines up with the y plus 1. And so 6y plus 6 equals 32. Subtract 6 from both sides. 6y would equal 26. Divide by 6. And y is, we can just divide by 2, 13 over 3. And we still need to get uv. I ran out of room, so I made it smaller. uv is y plus 1. Now that I know y is 13 over 3, to add fractions, we need a common denominator. So we're going to get 16 over 3 for uv. The two polygons are similar. Find a scale factor of polygon ABCD. So we can do side AB from that. Two polygon RSTUV. So we could do the corresponding side to that was RS. So that was our magic 6 to 4 that we used for both those proportions. If we reduce that, we get a scale factor of 3 to 2. Rectangle WXYZ is similar to rectangle PQRS with a scale factor of 1.5. If the length and width of rectangle PQRS are 10 meters and 4 meters, respectively, what are the length and width of rectangle WXYZ? So they gave us The sides are proportional because they're similar, so WX is to PQ, and they told us the scale factor is 1.5, and they told us PQ was 10, so WX is to 10. So to solve, what we have to do is multiply both sides by 10, and I get WX is 15, and then the same thing for QR. The scale on the map of a city is 1/4 of an inch equals 2 miles. On the map, the width of the city at its widest point is 3 3/4 inches. The city hosts a bicycle race across town at its widest point. Tashwanda bikes at 10 miles per hour. How long will it take her to complete the race? Well, before we can figure out her time, we're going to have to find her distance. So we can set up a proportion. We've got the map distance to actual miles equals the map distance, and we want to find the actual miles. So we could do cross products and divide both sides by 0.25. So she will be biking a mere 30 miles across this little city. And we know distance equals rate times time. So she's biking for 30 miles, and she's biking at 10 miles per hour. So at that rate, it would take her 3 hours. We've already talked about congruent polygons. If two polygons are congruent, they're also similar. All the corresponding angles are congruent, and the lengths of corresponding sides have a ratio of 1 to 1. So summing it all up, in similar polygons, the corresponding angles are congruent and corresponding sides are in proportion. The ratio of two corresponding sides in two similar polygons is the scale factor.